Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the uh, sixth part of the series in which we are discussing CSIR NET Physics PYQs of December 2019. So today we are going to solve part C questions. In last lecture, we have solved part B and part C questions. Okay, so today we are going to solve part C questions. And before starting the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes, which are going to help you to crack the exams related to physical science. Okay, so I'm going to start now. Question number 1. Question number 1, which is the strong nuclear force, the strong nuclear force the strong nuclear force strong nuclear force between a neutron between a neutron and proton a neutron a neutron and a proton neutron and proton in a zero orbital angular momentum state, zero orbital angular momentum state or angular momentum state is denoted by neutron and proton. Okay, is denoted by FNP. FNP, that is force between neutron and proton, which is function of R, where R is the separation between them. Similarly, FNN and FPP, FNN which is function of R, FNN which is function of R, and FPP which is also function of R, denote the forces between between a pair of neutrons a pair of neutrons and protons respectively in zero orbital angular momentum state, orbital zero orbital momentum state okay, which of the following which of the following is true, on average, if the internuclear distance if the internuclear distance inter internuclear distance internucleon distance, okay, internucleon distance, internucleon means proton and neutron, okay, internucleon distance is between 0.02 fm Fermi meter, right? Fm R is between 0.2 Fermi meter to 2 fm, okay. And options are, option A is FNP is attractive. FNP is attractive. FNP is attractive for triplet spin state. For triplet spin state. Triplet spin state. And FNN, FPP are always repulsive. FNN, FPP are always repulsive. Okay, option B is FNN and FNP are always attractive, okay, and FPP is repulsive. FPP is repulsive in the triplet spin state. In the triplet spin state. Triplet spin state. And option C is FPP and FNP. FPP and FNP are always attractive, there is some issue, are always attractive and FNN is always repulsive, and FNN is always repulsive. Okay, and option D is all three forces are always attractive. All three forces are always attractive. Okay, so I'm going to start now. Okay, so question is very simple, which is a strong nuclear force a strong nuclear force between neutron and proton in a zero orbital angular momentum state. Okay, so between neutron and proton, the force between them is FNP, neutron and proton. Okay, where R is the separation between them. Similarly, FNN and FPP denote the forces between pair of neutron and pair of protons respectively in zero orbital momentum state. Okay, which of the following is the correct, right? This you need to find out, and uh, so this is, you need to find which of the following is true on average which is true. Okay, if an internuclear distance is between 0 0.2 fm to 2 fm. Okay, very good question. So what we know about nuclear forces, right? That's what I'm going to explain. So solve it now. So inside the nucleus, inside the nucleus, inside the nucleus, inside the nucleus, the interaction between the interaction between neutron 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 and neutron proton and neutron proton neutron and neutron proton is always is always is always attractive is always attractive is always attractive due to nuclear force. Okay, attractive due to attractive due to nuclear force nuclear due to nuclear force. Whereas 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 between proton proton, the interaction between proton proton between proton proton is repulsive is repulsive due to Coulombic interaction, due to, because there is a proton, right, positively charged, right, due to Coulombic due to Coulombic interaction due to Coulombic interaction. Thus we can say FNM, FNN and FNP are always attractive, are always attractive, 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 and FPP, because of Coulombic force, is repulsive, right? So this we know now, right? Between proton proton, the force will be repulsive because of Coulombic force, and between neutron proton or neutron neutron, it will be attractive force, right? So which option is matching, guys? Which option is matching? Let me check. So the option B is the correct, right? Okay, so option B is this one, guys. Fn and Fnp are always attractive, that is correct, and Fpp is repulsive in triplet spin state. Okay, so this is the correct option. Very good question, guys. So you should know in nucleus because of nuclear force, right? The between neutron and neutron there is a attractive force. Between neutron proton, this is a there is attractive force because of nuclear force, and between proton due to Coulombic force it's repulsive force. Okay, and but in neutron and neutron proton the interaction will be always attractive. Okay. Okay, guys, so this is the question and this is the answer, right? Next question, guys. Question number 2. Question number 2 is, meanwhile just let me check is my voice audible, because this is very important. Many times there is issue with audio. Attractive due to nuclear force. Yeah, I am audible, guys. Thank you. Okay, I'm continuing. Okay, so question number 2. Question number 2 is, these are part C questions, guys. Okay, very good questions. The Hall coefficient, this is also very good question. The Hall coefficient, the Hall coefficient for a semiconductor, for a semiconductor, the Hall coefficient for a semiconductor having both types, having both types of both types of carriers, both types of carriers is given by, that is charge carriers. Okay, is given by RH equal to or given as, okay, given as RH equal to P mu P square minus N mu N square upon modulus of E, that is P mu P mu P plus N mu N whole square. Okay, so this is given. This is the Hall coefficient is given. Okay, Hall coefficient is given, where P and N are the carrier densities, the carrier densities of the holes and electrons mu P and mu N are their respective mobilities, mobilities for a n-type semiconductor, for a, my apologies, for p-type semiconductor, for a p-type semiconductor in which in which the mobility of holes, the mobility of holes, mobility of holes, mobility of holes is less than, is less than, so mobility of holes, okay, that is less than that of electrons, that of electrons. Which of the following graphs, which of the following, which of the following graphs best describes best describes best describes the variation of, the variation of, the variation of Hall coefficient, Hall coefficient with temperature, with temperature, okay. Now options are given. Let me write the option. So options are, so graphs are given, okay. I'm drawing those graphs. Option A graph is, this is RH, Hall coefficient, and this is temperature, okay, and graph is like this, this and this, okay. Option B is this one. These are straight lines, guys, okay. So RH, this is T, and this is RH equal to 0 here, and graph is like this, okay. And option C is, option C is, these are straight lines, okay. Graph is like this, T and RH. And option D is very good question. Graph is like this, RH, this is T, temperature, and the graph is like this. Okay, this is not correct, some mistake. Like this, okay. This is the graph. Okay, so these are the graphs which are given, okay. So now I'm going to solve it. So this is uh, if you are if you are fundamentally strong in physics, and if you have studied this properly, then you will be able to solve this question, okay. So these are the graphs which are given, and we need to select the correct graph, okay. So we'll analyze the question now, okay. So now, so first we have been given this, okay. We have been given Hall coefficient, that is this one, RH, okay. I'll write it again. So this is given RH, RH equal to, this is P mu P square minus N mu N square upon modulus of E, okay, charge of electron, into P mu P plus N mu N whole square. Okay, so this is what is given. Well, so now we'll analyze this question in three parts. Okay, first is at first case first is at low temperature. Okay, at low temperature we can see P that is number density of holes. Okay, charge carrier density of holes, P is greater equal to N. Okay, if this is the case at low temperature. Okay, the number of the hole density is, or charge carrier density of hole is greater than N if temperature is low. Okay, so in that case, and this is given in the question. Okay, mu P is given, which is less than mu N. This is a P type semiconductor, and for that we have given the Hall coefficient, right? And also mu N is the mobility of electron, and mu P is the mobility of hole, and it is given in the question the mobility of hole is less than mu N, right? I'll show you this one. This is given, okay, for P type semiconductor in which the mobility of hole is less than mobility that of electron. Okay, so in that case now we can get RH. Okay, since P that is charge density of hole is very high than N, right? So it means this term is going to be very high, though mu P is less than mu N, right? Mu N is greater than mu P, but this term is going to be very high, right? So this is going to give plus value, because in denominator we can see this is mod value and this is whole square. So this will always be positive in denominator, right? And because this value is very high, so this value then means the value of RH is going to be positive, right? From this, so the value of RH is positive at low temperature, because at low temperature the charge density or carrier density of P is greater than N. Okay, next the case 2. Okay, second case is at moderate temperature, that is not very low or not very high. Okay, at moderate temperature P upon N is greater than 1. Okay, so the ratio of P upon N is going to be greater than 1, right? So in that case because P upon N is greater than 1, right? So in that case this one P mu P, this value, because this ratio is like this, so this in this case P mu P square is going to be almost equal to P N mu N square N mu N square. Okay, because and since because this value is greater than 1. Okay, since we have been given that is mu P less equal to mu N. okay, mu p less equal to mu n, and so and p upon n is greater, the ratio of p upon n is greater than 1, right? So it is that, it means that this value and this value, these values are almost equal. It means RH value is going to be 0, okay, RH value is going to be 0. So in that case, this is, now we'll study case third, okay. Case third, case third is case third is at high temperature, okay. So at low temperature we have seen the condition, at moderate temperature also we have seen uh, the condition. Now at high temperature, at high temperature, at high temperature, P upon N is going to be almost equal to 1, okay. P upon N is going to be almost equal to 1. So this means, and since we have been given mu P is less than mu N, right? This is we have been given, right? So in that case, we can see, uh, uh, so we can say this P upon N equal to almost equal to 1, right? Means P is almost equal to N. So this value, the value of RH is going to be, this value is greater because mu N is greater. These are P and N are almost equal. So this is greater, means this is going to give negative value, right? So RH is going to give negative value. So RH going to be negative value. That means RH Hall coefficient, that is RH is less than 0, okay. So now from these three cases, so you can see at low temperature RH value is at very high temperature RH value is greater than less than 0, at moderate temperature RH value is 0, and at low temperature RH value is positive. So if we check the graph, if we check the graph, right, so only option D correctly represents the variation of RH with respect to time, right? Because you can see it is for low temperature RH is positive, and at moderate temperature RH value is 0, so here it's 0, and at high temperature the value of RH is less than 0, right? So option D is the correct option. Well guys, this is the question. Next question we are going to solve. Next question, this is also very good question. The question is, question third, the generator of the infinitesimal of the infinitesimal the generator of the infinitesimal canonical infinitesimal canonical infinitesimal canonical canonical transformation, that is q dash equal to 1 plus epsilon q, and p to p dash is equal to 1 plus 1 minus epsilon 1 minus epsilon p 1 minus epsilon p is, okay. Options are Q plus P, option B is QP, option C is 1 by 2 Q square minus P square, and option D is 1 by 2 Q square plus P square, okay. So the question is given, the generator you need to find out, okay. So generator of the infinitesimal canonical transformation. So there is a canonical transformation which is very less, okay, very small, and this is the Q is Q dash, that is 1 plus epsilon Q, and P dash to P dash equal to 1 minus epsilon P, okay. So generator of the infinitesimal canonical transformation is, so we need to find out generator for infinitesimal canonical transformation, right? Very good question. So how to get it, we'll solve it, okay. So we have been given this Q dash to Q dash equal to 1 plus epsilon Q, okay, and P dash to P dash equal to 1 minus epsilon P, okay. So this is what is given. So now we'll find P minus P dash. P minus P dash is going to be this is P minus Q dash is this, right? 1 plus epsilon Q, right? So this value is going to be and outside this is this one, okay. P minus P dash, so this is Q, one plus epsilon, we have written wrong here, this is outside P, outside Q and outside P, okay. So this is going to be outside P, right? So if this value is going to be minus, PP will get cancelled, so minus minus epsilon P. Similarly, Q minus Q dash is going to be Q minus 1 minus P minus P dash minus P, correct? 1 minus Q. We have made something wrong here. So this is going to be P dash minus P, guys. We have made mistake. Okay. So this is this is going to be, this is P dash minus P. So this is 1 plus epsilon P minus P, right? This value is going to be just wait, what mistake then? This is 1 minus, guys, because we are doing with P, right? So this is 1 minus. So PP will get cancelled. This is going to be minus epsilon P. Similarly, Q dash minus Q, that is going to be 1 plus epsilon. Just give me 1 second, guys. Yes. So this is one plus epsilon P minus, sorry, Q minus P, right? And this value is going to be Q minus Q, okay. So this value is going to be epsilon P, right? So these are the value. Now there is a formula for getting the generator, okay, for infinitesimal transformation, okay, canonical transformation. So that is I'm going to write it. So this is minus epsilon del G upon del G upon del Q equal to P minus P dash. Okay. The another is epsilon dg upon G is the generator. Okay. Del P equal to Q minus Q dash minus Q. Okay. This is P dash minus P dash minus P. Okay. So this we have the formula, right? So now this is P minus P dash equal to minus epsilon del G upon del Q. So P is a momentum will be minus, okay, and coordinate will be positive, okay, del G, and respect there is a P, so differentiation will be with respect to Q. There is Q, the differentiation will be with respect to P, okay. So now we'll put the value. So this is minus epsilon dg from 1, okay, from 1 minus epsilon dg upon dq is going to be equal to P minus P dash value we have got, that is minus epsilon P, minus epsilon P. So minus minus will get cancelled, okay, and epsilon will get cancelled, and so this is going to be dg upon dq is going to be P, right? So this one, okay, so this is going to be dq, and so we'll integrate it. This is going to be del G equal to P del Q, will integrate it. So this value is going to be G equal to PQ. Similarly, this one, similarly, this one from 2 to it is going to be sigma del G upon del P is going to be, this is epsilon P, epsilon will get cancelled, so del G is going to be P del P integration, and from here also G equal to PQ, right? So the value, so you can see here the value, that is that is the value of generator is PQ. You can use any one of them, okay. So we can check all options, but right, so we can see G equal to QP, and which is matching, right? So which option is matching, guys? Option B, okay, QP or PQ, same. Next question, guys. So question number 4, right? Question number 4 is